A mail-order catalog firm designed a factorial experiment to test the effect of the size of a magazine advertisement and the advertisement design on the number of catalog requests received. 3 advertising designs and 2 different size advertisements were considered. The data are as follows. Use the ANOVA procedure for factorial designs to test for any significant effects due to the type of design, the size of the advertisement, or interaction. Use alpha equal 0.05. So to solve this problem, we're going to fill in the following ANOVA table. Starting with the degrees of freedom, the total degrees of freedom is equal to the total sample size of 12 minus 1, which comes to 11. The degrees of freedom for size, there are 2 different sizes, and 2 minus 1 comes to 1, so 1 degrees of freedom for size. Degrees of freedom for design, there's 3 different designs, so 3 minus 1 comes to 2, so 2 design degrees of freedom. And then the interaction degrees of freedom, if we multiply the size degrees of freedom by the design degrees of freedom, 1 times 2, we get 2 for the interaction degrees of freedom. And then the error degrees of freedom is what's left over. 11 minus 1 minus 2 minus 2 comes to 6. Next, the sums of squares. Starting with the total sum of squares, using the formula in the textbook, we obtain 544 for the total sum of squares. Next, the sum of squares for size comes to 48. The sum of squares for design comes to 344. And the sum of squares for interaction comes to 56. Then the error sum of squares is what's left over. 544 minus 48 minus 344 minus 56 comes to 96. The mean squares are the sum of squares divided by their degrees of freedom. And then the F statistics are the mean squares for size divided by the mean square for error. That F statistic is 3.00. The mean square for design divided by the mean square for error comes to 10.75, and the mean square for interaction divided by the mean square for error comes to 1.75. Next, to find the p-values, we're going to need to look up F-distribution tables for the p-value corresponding to the F statistic 3.00. We're going to use an F distribution with 1 numerator degree of freedom and 6 denominator degrees of freedom. And 3.78 has an upper tail area of 0.1. The F statistic 3.00 is to the left of 3.78, so the tail area for 3.00 must be bigger than 0.1. In other words, the p-value is bigger than 0.1. For the other 2 F statistics, we're going to use the F distribution with 2 numerator degrees of freedom and 6 denominator degrees of freedom. And 3.46 has an upper tail of 0.1, while 7.26 has an upper tail of 0.025. So first looking at the F statistic for design, which is 10.75, that is to the right of 7.26, so the tail area corresponding to 10.75 must be smaller than 0.025. In other words, the p-value is smaller than 0.025. And finally, the F statistic 1.75. 1.75 is to the left of 3.46, so its tail area must be larger than 0.1. In other words, the p-value corresponding to that F statistic is larger than 0.1. So looking at those 3 p-values, there's only one that's significant at the 0.05 level, and that's the p-value for design. So for that variable, we reject the null in favor of the alternative. So there is evidence that the number of catalog requests depends on the advertisement design, but it doesn't appear to depend on the size of the advertisement or the interaction.